Okay, I will be sitting down for the meantime. I want to introduce myself. I'm Professor David J. Delos Reyes. Okay, my long video format discussion for tonight will be college algebra, lesson number 34. Okay, let's proceed. I will remove my chair. Okay, let's continue. My long video format discussion for this evening will be college algebra, lesson number 34. And the title of the topic is actually solution of a quadratic equation, okay, by using the quadratic formula. We pass by the solution by factoring, by taking the square root of both sides, by completing the squares. So for this evening, we will be presenting a solution which is very important in the study of college algebra, because for as long as we live, okay, this quadratic formula will not change. So for tonight, I will be deriving the formula, the quadratic formula. Okay, let's proceed. To bring out the fourth type of solution for quadratic equations, okay, we will be using a formula, and that formula is termed to as the so-called quadratic formula. But before I will try to derive the formula, quadratic formula, okay, I will try to give you a given condition. The given quadratic equation should be in the so-called standard form. For us to use this quadratic formula, the form of the equation, the quadratic equation, will be in this form here. That is ex squared plus bx plus c equal to 0. The right hand side should be equal to 0. There's nothing on the right hand side. And still, with the given condition, a, b, and c are all real numbers. And another condition is that a is not equal to 0. Because if a is equal to 0, we got a problem. The the equation is not quadratic, it's just linear. Okay, so for it to become a quadratic equation, a should not be equal to 0. Okay, let's try to derive the so-called quadratic formula. The quadratic formula, it will be this, okay? So try to memorize this by heart, whether you are sleeping or you are drunk or you are somewhere else. Okay, this formula should be in your mind. That is x equal to the value b preceded by negative sign, plus or minus the square root of b squared minus 4ac, the square root, all over 2a. Okay? So in here, a should be given, b should be given, and c should be given to use this equation here. Because we must have to specify the correct values of a, b, and c for us to use this. Okay, let's try to bring out the derivation of the quadratic formula. Let us see if you have mastered the solution by the so-called completing squares. Because the solution of the quadratic formula, or the derivation of the quadratic formula, emanates actually from the so-called solution by using completing squares. Okay, let's proceed. Ex squared plus bx, first step, all constant terms to the right. So this should be negative c. Okay? So, next step. We must have to eliminate that a on the coefficient of x. So we will multiply all the terms by 1 over a. So ex squared times 1 over a will be x squared. Bx times 1 over a will be the ratio b over a times x. And negative c times 1 over a will be negative c over a. Okay? Then try to complete the squares. That's why the solution is by using completing the squares. And the rule from our previous discussion, for the left-hand side to become a perfect trinomial, okay, we will take 1/2 of the coefficient of x. Then we try to square that one. we raise it to the second power. The coefficient of x is actually b over a. So this should be b over a. We take 1/2. Okay? Then we square it. Okay? So if we try to square this one, 1 times b will be b. We square it, that will be b squared. Okay? 2a, 2 times a will be 2a. We square it, it will be a 4a squared. So the needed constant for the left-hand side to become a perfect trinomial, we must have to add the value b squared over 4a squared. So I place it here, x squared plus b over a times x. Okay? Then we add the computed value, this one, on the left-hand side. And this should be equal to negative c over a. Since we add this one to the left, we must have to add this one also on the right for the value of the equation not to change. So actually, we add it, we don't change the value of the equation. After the addition of this one, like what I said in my previous discussion, okay, it will now be factorable to the binomial x plus b over 2a quantity square. And for the right hand side, there is a problem. We are adding two fractions with different denominator. Okay, so like what is coming out on the short videos, we use the butterfly method. We try to multiply this one, right? Then we try to multiply this one. Then the resulting denominator will be the product of the denominators. So a 4a squared times negative c will be negative 4a squared c. Okay? And a, and this is a. And a times b squared will be ab squared. And the resulting denominator will be the product of the two individual denominators, a times 4a squared, which will become 4a cubed. So we combined already the given right hand side by using our knowledge on how to simplify two fractions with different denominators. So it's just our lesson from the previous lessons. Okay, that's why we started from the fundamental operations, because without knowing those things we cannot proceed here. Okay, and for the right hand side, like what I said, this is factorable to the quantity x plus b over 2a quantity square. Oh, let's try to expand this one. If what comes out is really this expansion here. If we try to expand x plus b over 2a quantity square, let us try to see if the expansion of this will be equivalent to this. Because we said that this expansion is factorable to this binomial. The square of x will be x squared. Right? The middle term will be twice the product of x times b over 2a times x times b over 2a. The last part will be the square of b over 2a, which will become b squared over 4a squared. The first term is correct, right? The last part is correct, the one we add. The middle term, these two here cancel with these two. Okay? So what remains, if we try to expand this, the middle term is actually the product of b over a times x. It is this. That's why, as I have said, this expansion here, which is now a perfect trinomial, will be factorable to the binomial x plus b over 2a quantity square. Okay? And for the right hand side, it is this. Then again, we try to factor out a here. We bring out a. So what remains will be b squared minus 4ac. For the bottom portion, okay, we segregate a times 4a squared. That's why this a here cancel with this. Okay, so what remains will be x plus b over 2a quantity squared. A cancels already, so what remains on the numerator will be b squared minus 4ac. 4a squared is 2a quantity squared. Then we try to raise both sides of the equation to the 1/2. The enemy of 2 will be 1/2. Okay, so we raise this 2 total left and right to the 1/2. So these two here cancel with this. It will just be simply x plus b over 2a. And for the right hand side, we all raise this to this 1/2, right? Or it seems we are taking the square root, right? And under the square root, the square root of two fractions will be the square root of the numerator all over the square root of the denominator. So actually, we could segregate this one. So this should now be b squared minus 4ac all over the square root of 2a squared. We are just lucky. A 2a quantity square, we raise that again to the 1/2 power. These two here cancel with this. So what remains for the square root will be 2a. So after taking the square root of the denominator, it is now just simply 2a. Right? And to compute for x, we transpose this b over 2a on the right. So x now will be negative b over 2a. The value of the square root of b squared minus 4ac, okay, it's either plus or minus, right? So this is plus or minus the square root of b squared minus 4ac all over 2a. Then we try to combine these two fractions here. Luckily, the denominator are the same. So x now will be negative b plus or minus the square root of b squared minus 2ac all over the common denominator 2a. And this is termed to as the quadratic formula. Like what I said, even though you are dreaming, you are sleeping, you are drunk, or you are eating, okay, this formula, you don't forget it. And this is termed to as the so-called quadratic formula under the study of algebra. I will repeat it. X will be equal to the value of b preceded by negative sign plus or minus the square root of b squared minus 4ac all over 2a. That's the derivation of the quadratic formula by using the so-called completing squares. Okay, let's try to bring out the four kinds of solution. Because there are four kinds of solution with this given quadratic formula. Kinds of solution, in our textbook, the term that one as the determinant of b squared minus 4ac. But for me, I just simply place kinds of solution. Discriminant, if you don't understand what is discriminant, there's a problem. But in layman's language, discriminant will be just kinds of solution, right? There are four cases. The four cases will be this. I will try to erase this one. So it will look good, right? Case number 1. If the value of b squared minus 4ac under the radical is a perfect square. An example of a perfect square, if what comes out inside the radical is 25, okay, that is termed to as a perfect square. Okay, if the value of b squared minus 4ac inside is a perfect square, there are two rational values for x. There should be x1 and x2, and they are both rational. Okay, rational meaning they are exact, right? For case number 2, if the value of b squared minus 4ac is positive, non-perfect, okay? Positive non-perfect, an example of this, if what comes out inside the radical side is 26, right? This is not a perfect square. So the 26 is an example of a so-called positive non-perfect. And there will be two values of x also, x1 and x2, and they are irrational. Irrationally, they are not exact. Right? 26. Case number 3. If the value of b squared minus 4ac equal to 0, okay, if this portion here is 0, right? X1, okay, x1 is equal to x2. Okay, x1 is equal to x2 because by using the positive sign, there will be an x1 which is negative b over 2a, and then by using the negative sign, the value is still negative b over 2a. That's why I place it here. If b squared minus 4ac is equal to 0, x1 is equal to x2. Okay? Case number 4. This is the worst case scenario. Right? If the value of b squared minus 4ac equal to a negative number, Meaning if the value of what's inside is a negative, example lang, 36. It is a number, but this is preceded by a negative sign. Okay? So we got a problem. If it comes out like this, the rows will be a complex rows, right? There will be a real part and the so-called imaginary part. Because to simplify a number with the square root inside, we must have to introduce the value I square equal to negative 1. Right? So what comes out for case number 4, if the value of b square minus 4ac is negative number, x1 and x2 are both imaginary. Okay? Or imaginary meaning complex number. Complex. There should be a real part plus or minus I imaginary part b, something like that. So the combination of real and imaginary, it is complex. Okay, so x1 and x2, it will be complex or imaginary. So at least we now know how the, variation of the value of b square minus 4ac come out. Because if we know how it will come out, we could predict what will be our solution. Okay, let's proceed with an example problem. Oh, this is an easy one. We call this the so-called direct substitution solution. Okay, example number 1, solve by using the quadratic formula. We are given the quadratic equation 3x squared equal to negative 8x minus 5. Solution. Step number 1, we must have to, bring back or simplify the given quadratic equation for it to become under the so-called standard form. It should be under this form here. Okay? The right-hand side should not be any value. There should not no variable, no constant. The right-hand side should be 0. So we must have to eliminate the values on the right-hand side. Right? So 3x squared, we both transpose, right? It will become 8x plus 5, and this should be equal to 0. So after the transposition, what comes out will now be the standard form of the quadratic equation. It is of the form ex squared plus bx plus c equal to 0. So actually, we could specify that the value of a will be 3, meaning the coefficient of the square term. The value of b is actually 8. This is 8. The coefficient of x. And the pure constant term is actually 5. Okay? So if we try to determine what type of solution that will come up from here, we will use the kind of solution or the discriminant of b squared minus 4ac. So we will just use this equation here, then try to substitute values. That's why I told you this is a direct substitution solution. Easy money. Sabi nila sa Pilipinas, CCU. Okay? CCU, that's not a joke. CCU is just an easy term, right? So if we try to compute for b squared minus 4ac, it will be 8 squared minus 4 times 3 times 5. Simplifying this one, it will be 64 minus 60. 64 minus 60 is positive 4. It is plus. Okay? So it falls under case number 1. It is a perfect square. And it is positive. Right? Positive perfect square. So if we go back now to this formula here, this is now an easy money, or again, it's CC, right? So this is a negative open quantity A plus or minus the square root. We computed already the value of b squared minus 4ac separately, and that is actually 4. So you don't have to follow this one again. You just substitute 4. Square root of 4 all over 2 times 3. So this should be, I place a quantity here because in this formula, the sign of b will be positive because just in case b is negative, there's a problem, right? And if you don't place a quantity here and the sign of b is negative, you are wrong, right? So negative open quantity plus 8 will be negative 8. This is plus or minus 2 over 6. x1 will be by using the positive sign. Minus 8 plus 2 over 6. So that will be 6 over 6. Or negative 6 over 6. And the value, the first value will be negative 1. Okay, x2. negative a using the negative sign minus 2 over 6. So it will become negative 10 over 6 divisible by 2 both. So this is 5 negative over 3. So the second answer will be negative 5 thirds. Okay? Oh, that is a direct substitution solution. Okay? We call it easy money. In the Philippines, we call it sisig. Right? There should be no problem in that one. Last example for tonight. Solve by using the quadratic formula. A little bit, it's not complicated. It is not yet in the so-called standard form. 2x squared minus open quantity x plus 2 times x minus 3 plus quantity equal to 12. So obviously the given quadratic equation is not yet on the so-called standard form. So we must have to bring out its form for it to become standard. So we will just expand this one, right? So 2x squared, the product of two binomial. First term will be x squared, 2x minus 3x will be negative x, positive 2 times negative 3 will be equal to negative 6, close quantity. This 12 here, we put it on the left, negative 12, and this should not be equal to 0. Okay? Then try to combine similar terms. What comes out will be an x squared plus x minus 6, and this should be equal to 0. So this is now the standard form. Okay? The coefficient of the square term is 1, the value of b is 1, and the value of c, it should be negative 6, because under the standard form, that plus c is actually with the plus sign, right? And what comes out here is a negative, so meaning to say, the value c is actually negative 6. So c is negative 6. Let's try to determine what type of discriminant or type of solution that will come out over here. So we will perform b squared minus 4ac. I am still on the camera. B squared minus 4ac, so this is 1 squared minus 4 times 1 times negative 6. We are just lucky, this is negative and this is negative, so the terms for the simplification of this will add, right? So 1 plus 24, 1 plus 24 is 25. And what is 25? 25 is a positive perfect square. So again, it falls under case number 1. The discriminant or the type of solution for this given quadratic equation after the transforming to standard form, what comes out is actually case number 1. So by using this quadratic formula, this should be negative open quantity 1 plus or minus, okay, we will go automatic, we lack space already. The square root of 25 will be plus or minus 5 over 2 times 1. And x1 will be positive 2 by using the positive sign. And x2 will be equal to negative 3 by using the negative sign. Negative 1, negative 5 will be negative 6 over 2. That will be negative 3. Okay, that's it, guys. Algebra is just easy. Okay, if you know your fundamental operations, that's why we started with the fundamental operations. Don't be bored. We are running smooth. So for those of you who are taking up college algebra or just reviewing college algebra, this is for you guys. If you want to subscribe to my channel is at youtube.com/@ProfDavidJDelosReyes. If you want to share it, please click share. Okay, I will be telling you this one. Try to watch my video format discussion on algebra. You will learn something from it because the problems on all the short videos, the solution is actually the concept. So without knowing the concept, you cannot solve those short videos. Okay, good evening from Los Angeles, Professor David J. De Los Reyes.